So going from a formula to the name for multivalent is tricky. So this is why I said we're going to skip that, we're going to skip that, and we're going to jump straight to polyatomic ions. What are polyatomic ions? They're on the back of your periodic table. They are these ones here. These are ions because they have a charge. They all have like a +1 or a -1 or a whatever. But they're polyatomic because they're made up of more than one atom. How do these work? So polyatomic ions act as a atom, as a big uber atom, as a single atom. And they can bind to positive ions or negative ions. Atoms inside a polyatomic ion. So let's look at one. Here's one called chromate. CrO4, 2 negative. The chrome, the chromium, and the oxygen, those are binding covalently by sharing electrons. But then once they bind covalently by sharing electrons as a group, they'll bind ionically with something else. So Ariel, atoms inside a polyatomic ion are held together by covalent bonds. Polyatomic ions form ionic bonds with other ions. If you're not sure whether you're dealing with the polyatomic ion, Oren, are you on your... No, never mind, you're eating something. Okay, sneakily. No, I know. Okay. If you're not sure if the formula that they've given you has a polyatomic ion, the easy trick is just count the number of capital letters. If there's only 2 capital letters, there's no polyatomic ion. That means you can just use your regular naming with the "ide" rule. If there's more than 2 capital letters, then it's a polyatomic ion. And again, Cassandra, the rules change. Ugh. But thankfully, the rules don't change too difficult. Okay? Oh, yeah. So if you see more than 2 capital letters, you're going to be using the back page of your periodic table. I asked the cat sitting next to me if he had any sodium hypobromite. He said, "Nah, bro." I told a chemistry joke. There was no reaction. Okay. So, the names of polyatomic ions.
How do you find this funny?
Don't change. Okay. The names of polyatomic ions don't change. So for polyatomic ions, there is no "ide" rule. You just use the name. Okay? So you don't have to use "ide" rule. Really, the trickiest part is recognizing that the polyatomic ion is there is the toughest part. So again, Aiden, the trick is count capital letters. More than 2 means polyatomic. So it's easier, I think, if we just do some together. Okay? So we're going to name some compounds together. Yep.
Can you slow down so
I can go a little bit slow, but I also got to kind of get through the lesson before. So we'll find a balance. I know it's tricky. If you're not a quick writer, ask me later and I can always bring it back up again as well, because that works. Or I can print this up for you. Door should be cracked open. Oh, hi there. Who are we looking for?
CD, please. For a moment.
Okay. So let's do one. Name these compounds. Okay? Okay, yes, first part absolutely hasn't changed. I heard somebody say sodium. Let's write that down. Yep. Then, do you notice how we have, no. Is there more than 2 capital letters? Look on the back page, you have SO4. What's it called? No. Is there more than 2 capital letters?
Yes.
Then this is a polyatomic ion. Look on the back page of your periodic table. You have a name for SO4. Sulfate? Look on the back of your periodic table. If you don't have your periodic table flipped over, you can't do this. Okay? So SO4 is way down here, and we call that sulfate. This is why I said you want it out of your binder, Jaden. This is why I said you want it out of your binder so you can flip back and forth. Okay? Jaden? Okay, but get it done. Ca. Calcium. NO3. Nitrate. Okay. What's NH4? Ammonium. Cassandra, you asked a great question. Can I come back to you with that in about 30 seconds? Ammonium. And then Cl. But now, now it's going to be the ide rule, because that's not polyatomic. So it's going to be ammonium chloride. MgOH.
Magnesium or something.
What's OH? It's on the back page. Hydroxide. Do you need to memorize these?
Yes.
Did I give you them on your periodic table? Do you need to memorize these? No. You might memorize a couple of them because you're lazy and you get sick of looking them up. And that's really the only reason you should memorize stuff, because you're lazy and you get sick of looking it up. But I will not ask you any that are not on your pink periodic table. Oh, and please, hopefully you figured out, you bring your periodic table to every quiz, every test. That's what you're allowed to have with you. Before we turn the page, Cassandra, do you remember your question? Or before I turn the page? You said, how come there's brackets? Okay, so here's what we're saying. What's the charge on calcium? Can you look on your periodic table? If we did the crisscross rule, what's calcium? 2 plus. And what's the charge on NO3? Just minus. When I crisscross, I'll have 1 calcium. How many NO3s do I need? Well, I guess I better put it in brackets to let people know that I need 2 of those. Okay? By the way, how many calciums are there in this molecule? 1. How many nitrogens are there in this molecule? 2. How many oxygens are there in this molecule? 6. Okay? I know, it's tricky. Okay? 1 calcium, 2 nitrogens, 6 oxygens. So basically, it's sort of like FOIL that you learn in math, or front door bomber if you have Mr. Rocca. You multiply out of the brackets. In this one, how many magnesiums? 1. How many oxygens? Not 1, but 2. How How many hydrogens? Not one, but two. I know, we're going to practice it. Okay? Can you help Ava figure out where we are? Quietly. Thank you. So, I think you have... Oh, let's do a couple more here. I didn't include these with you, so you can just do this looking up. What would you call CaCr2O7? Is there more than two capital letters? So it's polyatomic. What's Ca? Calcium. What's Cr2O7? Dichromate. It's on your sheet. You look on the back of your periodic table. Okay? It's okay. This is tough. You're allowed to be confused. It's not in your notes. We're just doing this together. More practice. You said you wanted more practice. BaCN2. Barium. Barium. And what's Cn? Cyanide?
Don't exist.
There you go. KClO3. Potassium. And you have to pronounce it very carefully because there's chloride, chlorite, and chlorate. So which one is ClO3? Chlorate. Chlorate with an A? Okay. Let me pause. Can you all see where we're getting these names from? They're on the back page. You don't need to memorize them, but you have to be able to spot them. That part I can't help you with. What would I call K3PO4? K, potassium. PO4 is phosphate. Psst. These ones are multivalent, and I'm skipping those. That's why they're nasty. So, you all have a chart to fill in here. Let's just add a little bit in our notes. So you treat the polyatomic ion as one atom. What that means when you're doing the crisscross rule is if you need more than one, you need to put brackets around the whole polyatomic ion. Till noon. I'll build in some breaks. I know. It's okay. So, quiet please. Sodium hydroxide. How would we get the formula? We're going to do the crisscross rule with polyatomic ions. So sodium goes there. What's its ion charge? Plus. Hydroxide, is that OH? What's its ion charge? Oh, this is a lovely crisscross. 1 and 1. So Nick, this would just be NaOH. And you would call that sodium. Guys, I need you to stop talking. I'm sorry, but I feel like I'm talking over people and I don't want to do that. This is really the toughest stuff and it's important. So you would call this sodium hydroxide. Okay. There are 1, 2, 3, 4, 5, 6, 7 in chart number 10. If you want to try them on your own, you can. I'm going to freeze the screen and every so often I'll bring up some answers. So try these ones on your own, please.